value that you would be getting is for the P1. Okay, so simply what you have to do is you have to put some values that you already have in your hand, that is ry square, and then rx square is there. Similarly, rx square value is with you. Okay, so based on this, whenever you put this value, you'll be getting value of P1. The very first thing I will show you is minus 332, because based on the calculation that we just have performed. Okay, so minus 332, that is less than 0 in our case. Okay, so if it is less than 0, then what it says is, if P1k is less than 0, we select yk plus 1 equal to yk. Keep this thing in mind. Okay, if it is less than 0, so yeah, our case is getting satisfied. So what you have to do is yk plus 1 equal to yk. So in our case, what we have is the value of yk equal to 6. So we have to keep it as it is. You don't have to increment or decrement it. You just have to keep it as it is. If this is the case, that is, it is less than 0. And at each and every stage, based on our algorithm, what we have to do is we have to increment the x value. That is for sure. In region 1, as I told you earlier also, in region 1, if you are like going with the ellipse generation algorithm, you have to yeah, initial point is fine. You have this thing with you, that is 0, 6 in our case. Okay, so that is the very first thing that we got out of the algorithm. Okay, so that you keep it with you. Okay, that is fine. And yeah, what is this in P10? No, this is P1 0. Yeah, so no, you don't have to put it in the table, or yeah, it is fine if you put it. That is the very first thing that you get out of the particular thing is without calculating anything. Okay, so that is considerable. So you don't have to like think कि अच्छा ये काम का नहीं है. That is considerable. You have to simply consider and keep it with you. Okay, so very first thing, less than 0. If it is less than 0, then what? Then what it says is select yk plus 1 equal to yk. In our case, yk plus 1 equal to yk. तो क्या हो जाएगी yk plus 1 की value? It would be 6 in our case. Okay, so now that's why we have like kept it like this, that is incrementing x value by 1 and keeping y value as it is. So this will be 1 comma 6, the very first thing that we got. Okay, similarly, what you have to do is you have to check this thing. As I told you, you have to check this particular calculation at each and every step, that whether you are getting out of the region 1 or not. So you have to check this thing. If this thing is getting satisfied, then what you have to do is you have to simply switch from region 1 to region 2. Okay, now based on our algorithm, what we have to do is we have to again, if it is less than 0, then we have to consider this particular equation for decision parameter at this intermediate stage. Okay, so you try to put your values in this particular equation and try to get the value. Based on the value, if it is less than 0 or greater than 0, we'll be making some decisions. So basically we have one condition, that is less than 0. We'll see the same thing. If it is greater than 0, then what? Okay, so try to put your values in this thing. देखो अभी करना तो पड़ेगा आपको. You have to try this thing by your like own, and then try to put each and every, then you'll be able to get कि यहाँ पे x की value क्या रखनी है. Similarly, xk plus 1 क्या है, yk क्या होगा. So you have to put this thing like that. Okay, so in our case, what it says is the yk plus 1 value is equal to yk. So you have to select yk value in this case. So our yk value is 6. Okay, similarly yk is 6, so you have to put 6 over here in our equation. Okay, but else everything you have. Okay, so basically what you have to do is you have to follow this complete thing. Okay, based on this, what value you get, you just tell me. Okay, in the comment box. Yeah, not a problem, I'm giving you time. Now I'll let you do the complete example. Okay, not a problem. But you have to give me the values. Based on the value, you'll be making the decision whether to increment something or not. So in our case, we'd be having, if it is less than 0, then keep yk as it is. You just have to increment x value and keeping the y value as it is. Minus 152. No, that is wrong. Yes, Ekta, you are correct. Minus 224. So basically, who is this Vatsal Patel? You try to check each and every value. You just have 2 minutes and try to recalculate it. Okay, so our value is minus 224. Based on that, make the decision. क्या आएगा decision के बाद you just write the coordinate, next coordinate over here. It is less than 0. Write the coordinate. What happened? No, increment the value of x na. You been told now that at each and every stage in region 1 you have to increment x value, that is fixed. Okay, but what you have to do is you need to make the decision for y value. Similarly, in the region 2 you'd be like decrementing y value, and the similar way we'll be making the decision for x value. So for this particular region you have to increment x at each and every stage, and we are looking for the y value. So in our case it is less than 0, so that's why we have kept y as it is. So that is 2 comma 6. Okay, so put your value 2 comma 6, that is your next pixel position. Okay, and then try to get the new parameter. Okay, it is a decision parameter. So now the new parameter would be similar thing. Okay, similar equation. Try to get the new decision parameter. क्या आ रही है value? Check it. Yes, 0 comma ry. That is very like you have to consider that thing by default if you are considering this kind of example. Okay, I'll be giving you different cases. Um, so that you can check. But for this purpose, based on the algorithm, you have to plot your first point, that is 0 comma ry. Okay. So now the next decision parameter value you have to write again in the comment in the chat box. Minus 44 is the answer. Okay. So again the same thing. You'd be like incrementing the x value and keeping the y value as it is. So the next pixel that you get is 3 comma 6. Okay. Clear to you now? What you have to do is you have to again proceed further based on the minus value that we got. Again, the equation would remain the same. So what you have to do is you have to take the most recent values based on the previous iteration, and then again try to put all the values in this particular thing and try to get the value of the next iteration. Okay. So now it would be for the P13. Okay. So now try to get the new decision parameter, and again we'll make some decision based on that. Okay, check if it is positive or negative value. I think now you'd be getting positive value. This is what you have to keep in like mind in the examination also. Don't do this thing in like hurry and all. Take your time and perform the complete calculation, else you'll be getting mistakes. Okay, what's this thing 208 value for the next decision parameter? Try to check the values that you have considered. Because our y value is same, that's why we are considering yk plus 1 equal to yk, and that is what you have to follow, and everything remains same based on the previous iterations. That is what you have to consider. Okay, anyone can verify this thing? So now we have positive value. Okay, if you have positive value, then what you have to do is it is greater than 0. So you have to increment x value and decrement the y value. Yeah, okay. See, my chat box is not getting synced. Okay, yeah. So that is fine. 4, 5. Okay, very good. So then next thing is, again you have to like take the most recent parameters that we got, that is 4 comma 5, and now we have to like consider the complete thing. Okay, and we have to calculate the new decision parameter. Okay, so based on that, you'd be getting new value. Check if it is minus or plus. Okay, and check if it is getting satisfied or not based on our condition. So based on our condition, you try to increment or decrement the subsequent parameters. Okay. So next value is this updated Google Meet and all is giving some latency. I don't know what is the problem with the updated Google Meet. Okay, fine. So now we have one value that is minus 108. Okay. So based on that, it is less than 0. What you need to do is you have to like keep the y value as it is, and you have to increment the x value. Okay, so the next parameter you'll be getting is 5 comma 5. Yeah, it's minus 108. Okay, so next parameter will be 5 comma 5. Okay, so yeah, that is what you have to do. And similar in the similar fashion, you have to proceed further. You have to go ahead, and then you will be again considering that particular equation. Okay, for our purpose. So putting the values in the same equation, you'd be getting new value of the decision parameter, and this decision parameter would be equal to 288. You try to calculate it, even though you have the value, you try to calculate it by your own and try to get this value. That is a positive value, and it is 288. Okay, so again, if you have this value is greater than 0, then what it says is increment the x value and decrement the y value. Okay, up to this stage, you perform it and write in the comment box. What happened, Darsil and all? कहाँ गए तुम लोगों की बंद हो गया आंसर? Nimendra and all. Are you getting this value? That is 288. Okay, fine. Minus 108. Okay, based on that, try to make the next decision. So in our case, it would be 5 comma 5. And Yeah. So go ahead and get the new decision parameter. So that would be equal to 288. There's a problem with this app, Google Meet app. It is not getting synced. Yeah, fine. Okay. Okay. This is the most recent value that we have, 288. Based on that, we have decremented y value. Okay. So next thing again, what we are required to do is again calculate the new decision parameter. Okay. Based on the most recent value that we have, that is 4 and 5. And similar thing is to be calculated with the like latest value of the decision parameter. That is in our case, that is 288. So you'll be getting one new value, that is 244 in our case. Yeah, calculate it. You have time, you have 5 to 10 minutes. Do it, not a problem. Okay, good. Okay. So based on 288, don't look at the PPT. You try to make decision by your own, else you will be getting confused in the examination as well as in the tutorial part also. Okay. Yeah, for CG, scientific calculator is allowed, so don't worry about that. For particular CG subject only, huh? Not regarding the NM or other subject. I don't know about that. Again, what it says that we have one more positive value, it is 244. So what it says that you have to increment the x value and we have to decrement the y value as well. So you'll be getting 7 comma 3 symbol. Okay. So once you get this value, you have to check this thing also. So try to check this particular thing at this particular point. So if this getting satisfied, then what? Okay, so then everything will change for the ellipse generation. You have to go to the region 2, and for the region 2 we have a new equation for the initial decision parameter as well as for the intermediate decision parameter. Okay, so try to follow that thing again. Decrementing and incrementing the x and y values would change, the dimension would change, okay, in the region 2. Bridal तो अभी क्या करना है next? Yes, Jinendra, if it is greater than, you have to go in the region 2. Okay, so these are our like latest parameter that we have in our hand, that is 7 comma 3. You have to consider these parameters for the further calculation. Okay, you have to go in the region 2. The other also do it. I'm giving you 5 more minutes to do this thing. जिसका हो गया है, they can proceed further for the region 2. What happened, Ekta? That's still reserve and all. Once you're moving for region 2, yeah, calculate it. Okay, so we'll go to the region 2 part. Now, what it says is we have a new whole new equation that we have to consider. Okay, based on our algorithm, we have to go ahead and then, yeah, you just have to put the most recent value in this particular stage, that is x0 and y0 value. So, as we have just calculated, that is 7 and 3 in our case. The value you are having, that is ry and xy, sorry, yeah, ry and rx value. So, that is what you have to put in this particular equation. You try to find out the initial decision parameter for the region 2. Okay, don't get confused. Don't consider the old equation. Okay. So calculation should be stopped now, but you have to go to the region 2 reserve. That is the like switching criteria from region 1 to region 2. Okay. So very first value that we have in the region 2 is minus 23. So based on that, but obviously it is less than 0. Then what it says is if it is greater than 0, then what you have to do is you have to select xk plus 1 equal to xk. So what it says is you have to like keep x as it is, or if this is not getting satisfied, then you have to increment x value. Okay, so in our case this thing is not getting satisfied, that is it is not greater than 0, so we have to consider this case. So what it says is you have to increment the x value, and as I told you earlier also, you have to decrement y value in the region 2. Okay, so earlier we were having 7 3, but now what it says is based on our value only, you have to increment x value. The x value will be incremented to 8, and then similarly, y values will be decremented. Okay, if you are not getting this thing, just have a look at the algorithm. You'll be getting this particular thing. Okay, what is the decision to be made or what to decrement? As I told you earlier, also in the region 2, you have to decrement the y value because you are going in a curved direction, or you can say downward. So that should be decremented as you won't be getting the proper shape. Okay, so yeah, so based on that, you'd be getting the value that is 8 comma 2. Okay, so keep this thing with you, 8 comma 2. Proceed further, like go ahead with this thing. Okay, try to get the new decision parameter, but again the equation will change because we are at the region 2. We are in the region 2. We are the region 2. And what it says is one more thing you have to consider is yk. If it is getting less than or equal to 0, then you have to completely stop calculating the values. Okay. अभी देखो next value क्या आ रही है. We'll check the new equation if you don't have it with you. Okay. We have to like decrement the y na, because what you are doing is you are trying to form an ellipse. Okay, so basically if you don't increment the y value, then how would be you would be getting at that direction, in that particular direction. You're getting my point. You are trying to get the pixels, you're trying to plot the pixels, but if you don't increment this thing in the region 2, because you consider this thing, your slope is getting -1 at this particular stage from switching from region 1 to region 2, and if you don't decrement it, then you won't be getting that particular shape. Okay, else you would be getting a distorted thing, because we are at the like ellipse generation algorithm. Okay, so keep this thing in mind. In region 1, increment x at degenerated. Similarly, in region 1, decrement y value. Okay, try to calculate the p2 value, and what is the new value that you are getting is 361. Okay, सी ये एग्जाम में यहाँ पे कंफ्यूज मत होना, ये स्टेजेस पे कौन सी वैल्यू लेनी है. यू हैव टू कीप दिस थिंग इन माइंड. यू हैव टू प्रैक्टिस दिस एग्जांपल्स. ओके, ऐसा नहीं है कि यू जस्ट हैव like seen this thing or you have calculated one example and that is enough. This is not enough. You have to calculate, you have to practice it. Okay, so that you get each and everything correct. Okay, so now based on that, based on this, what it says is xk value we have taken is 8, and based on the x0 value that was 7. So we have simply put it in the equation, and then we try to get the new decision parameter. So based on that, we got one positive value. Okay, now it is not a negative value. We are having positive value. So if it is positive and it is greater than 0, but obviously then what it says is you have to keep x as it is, and you just have to decrement y. So again you'll be doing a new you'll be plotting a new thing. So that would say that okay, 8 is our x value, and you have to decrement y at each and every stage. So our new value would be 8 comma 1 at this stage based on the 361 value. Okay, keep x as it is if it is greater than 0, as it is written over here. Okay, and decrement the y value. Okay, if it is not the case, then what you have to do is you have to do the other thing. That is, you have to increment the x value. Okay. Again, considering this equation and going further, what it says is again considering the most like recent values for our purpose. So in our case, we are having 8 value. So we'll put it over here and try to calculate the decision parameter. Okay. So now we are again getting positive value greater than 0. What you have to do is you have to keep x as it is, and you have to decrement y. And if your y is getting equal to 0, then what it says is you have to stop the calculation. Okay, that is what you have calculated. Okay, all the parameters now you have with you. So what you have to do is you have to plot it on the graph, or you can simply do it in your notebook and try to get it in the first quadrant. Okay, because it has been asked for the first quadrant only in region 1 and region 2. Okay, if it is a complete like ellipse, then what you have to do is you have to use the symmetric property. Okay, in the remaining quadrants. Okay, remaining 3 quadrants. That is how you can go with this thing. Okay, so yeah, try to make a decision also based on 297 value. What it says is you have to keep x value as it is and decrement the y value. Okay, we have just simply done this thing, that is 8 comma 0, and that is what it says that if you get the y value as 0, then it gets equal to 0, and that is where we have to stop the calculation. So yeah, Rishabh, that is fine. You have to stop it over here, and these are the parameters, these are the pixels that we have just calculated. Okay. Okay, so initial point 0.06. Okay, as someone like asked me about this thing, you have to plot this thing also. Okay, similarly you have to go ahead, that is 1626 in the region 1. We have this thing that is 16, and then 26 is there. Similarly 36, and then 4, 5, 5, 5, 6, 4, and 7, 3. Okay, so you just have to plot it like this. And suppose if it is a 7, 3, then it would be over here. Similarly 6, 4 over here, and then we have one more thing that is 5, 5, so it will be here. Okay, so likewise you have to plot it on your in your notebook, and then go to the region 2. So what it says is the very first value that we have is 82. Try to plot it over here, 82, then 81, and then 80. That is where it says that you have to stop the calculation. Okay, this is the thing that you get in the first quadrant in region 1 and region 2 for the LU generation algorithm. You try to plot it in your notebook also, so that in examination you don't get confused with the with this pixel thing. Okay, I know it is very simple, but you have to do it in the examination also. See, complete grid is not required as it is shown in the PPT. You just have to draw it like likewise. So you don't have to draw this grid thing and then you have to put some gray color in it. It is fine. You don't have to do all of this stuff in the exam or in the notebook. But just try to like plot this thing. Okay, got the complete example. Fine. Shall we go ahead? Okay, so yes or no? Yes. Okay. Fine. Okay. So now we have one important thing in the computer graphics is the field area primitives. Okay. So we'll try to see this thing that what it says. Then okay. So what it says in practice, we often use polygons, we use different objects, shapes. Okay, and what we do is we try to fill it with some color, but we need to get it in the like basics of this thing, how it is like actually filling the color or how it is like drawing that particular thing or how it knows like the edges or the boundary of that particular polygon. Okay, it is not like that okay, you are giving some information to it. It is trying to detect like all of these boundaries of the polygon and try to fill it with the particular color. Okay, so that is what we do. Like there are two basic approaches for area filling on raster system. Because we are dealing with the raster system, so we'll see it in that particular perspective only. So what it says is we have two things. One way to fill an area is to determine the overlap intervals for scan line that crosses that area. Okay. So now what it says is one way to fill an area. So basically you have multiple scan lines or you have one single scan line that passes from that particular point or from particular row. So what it is that okay, one scan line is going from left to right and similarly other scan lines are getting like getting over it. Okay. So one scan line will be like doing something that will detect some edges or detect some boundary of that particular polygon. Okay, if you say if you are at your like first row, you are getting 1 point. Okay, that indicates the boundary of the polygon. It will keep this information with it, and the next line will overlap this particular thing, and it will try to fill that particular area with some particular color. Okay. Another method is to start from a given interior position and paint outward from this point until we encounter the boundary. Okay. So you'd be giving like one information to this particular algorithm to start from a particular pixel or from the that particular position, and it will go up to that boundary. Okay. Or you can also give the boundary by yourself, or it can also detect it by by itself only. So basically what it tries to do is it tries to like get that intersection point out of the given polygon. Okay, if it says that okay, I have like multiple intersection points, so you have this start point and you have this another end point. So from start point to end point, it tries to fill that particular thing with a color. Okay, but in this case you are giving the actual endpoints. Okay. Then we have one more thing over here, that is scanline polygon fill algorithm. Okay, so now what it says is for each scanline crossing a polygon, the algorithm locates the intersection point that are of scanline with the polygon edges. Okay, so your like scanline passes through this particular position, or it can start from the bottom or it can start from the top, and it tries to identify the like intersection point. By the intersection point, we can say that okay, it tries to like find the boundary of the particular object. Okay, and once it gets like multiple intersection points, then what it will do is it will try to store this information. Okay, so in our case, this intersection points are stored from left to right. So you try to see the scenario that is over here from left to right. We are going. This is the scan line that is passing through the particular object through a polygon, and what it do is it will simply get the intersection point. So if it passes from left to right, as you can see here, we have one intersection point. It will go like from left to right until it reaches to the another intersection point. So by this information, it will be having that okay, I have two things and I have to fill something in between. So from this buffer position between each pair of intersection point, it will try to like fill that particular thing with particular color. If you are giving it in your program that okay, I want to fill it with green color or something, then it will fill it in that particular position. So as you can see, based on the intersection point information, it will store particular color in that region. Okay, so likewise it tries to do from left to right. It will go and it will try to find out the intersection points. Okay, and once it encounters it, it will store it and it will simply color it from starting to the ending position. So now we have one problem over here that what it says is like intersection point intersecting scanline intersecting at vertex requires spatial handling. As we have seen, our like polygon is something somewhat different. We have like few thing at the top. What it says is for vertex we must look at the other end point of the two lines segment which meet at this vertex. Okay, so now if this point lie on the same side of the scan line, that point is counted as two intersection points. So now you'll be like looking at the few more things. You'll be having few more scan line that would be scanning your complete polygon. Okay, and for each and every scenario we'll check it that how it is going to fill it. Okay, so now we have first case over here. Our second scan line is going through a particular like region, that polygon, and what it says if this point lies on the same side of the scan line. Okay, so it is over here. Okay, these are the points that it is like intersecting points. Okay, and it will store this thing and it will check whether it is on the same side or same plane of the like above scan line or not. If it is like that, then what it says is it is counted as two intersection point. Okay, for our first scan line we have this thing and it will try to check this thing. Okay, it lies on the same plane as you can see. Okay, so it will consider it as a two intersection point, and in between what you already know is it will try to fill some color. Okay, so it will fill that particular area with that color. Okay, so now what it says is if they lie on opposite side of the scan line, then the point is counted as single intersection point. Okay, so now we have one more scenario over here that is given over here. So what it says is now this there is one point. Okay, so now it is not on the like the same plane. Okay, it is over like other plane, or it is not at the particular same thing. So what it says is this will be counted as the single intersection point. See, basic information it would get from the previous scan line only, because if your point is lying over here and the next line is going from the same plane, then it will try to check whether our point is at the same position or not. So for this line it will check this like corresponding pixel. Okay, it will encounter this thing that okay, we have this similar thing from the previous pixel information or from the previous scan line. It will say now this is a boundary. Similar way it will go from line by line from like bottom to top or top to bottom. Okay, and it will check this information like from the above pixel or from the below pixel, and it will try to identify the boundary. Okay, यहाँ पे एक intersection point बना, so we'll try to build one like one line or some kind of shape. Okay, यहाँ पे okay, one intersection we got over here, one intersection we got over here, similar way over here and over here. So similarly it will try to make a like boundary, okay, of that polygon, and it will go somewhat like the same way. It will go and it will check for here also, but we don't have in between anything like that. So it will check the previous pixel. Okay, at this particular scan line we got one pixel, and at this scan line we got one another pixel. It will try to check, okay fine, we have this complete boundary. In between we don't have any other pixel, so we have to store the information of each and every scan line, and based on that it will try to make the decision that okay, I have to fill that area or not. Okay, so that is what it will do. It will try to find out the boundary and it will itself try to like create a complete object, and once it get this information, it will like simply fill it with some specified color. Okay, so that is what it tries to do. And then yeah, okay, so now we have one thing that is edge intersection calculation with scanline. Okay, so now coherence method often involve incremental calculation applied along a single line or between successive scanline. As I told you, this is like a like recursive process, or you can say you have to do this thing at each and every stage. So what it says is we'll try to get something that is edge intersection selection calculation with scan line. So we'll try to build something, build some equation, or we'll try to find some equation so that we can do this thing at each and every step. Okay. So in determining edge detection intersection, we can set up incremental coordinate calculation as we did in the previous example. We'll try to get this thing an equation so that could be used to get the particular information, okay, for that particular scan line. And if we get this particular information, then we'll be able to define the boundary. Okay, so we'll see this thing how we can do this thing. What it says is we can set up incremental coordinate calculation along any edge by exploiting the fact that the slope of the edge is constant from one scan line to the another. So multiple scan line, for that we have to like consider one thing, that is the slope of that particular thing, and that is constant in our case. So based on that property, we'll try to find out some equation. So what it says, we can write slope equation for polygon boundary as follow. Okay, so m equal to yk plus 1 minus yk, because we are dealing with the previous and the next information. So yk plus 1 minus yk, similarly xk plus 1 minus xk, again we'll consider. And what it says, since change in y coordinate between two scan line is simply this thing. Okay, so that is what we have seen. We have like gone in that direction only, incrementing one at a time. That gives us this value, that is yk plus 1 minus yk will be equal to 1. Okay, so now what we'll do is we'll try to substitute this value 1 with in the above equation. Okay, so we have this equation. In this we'll try to simply put it, and we'll be getting m equal to 1 upon xk plus 1 minus xk. Okay, so now what it says is we have to like make this thing as a subject. So that is xk plus 1 minus xk, and you'll be remaining with the inverse slope. Okay, that is 1 upon m. And making this thing as a subject, that is xk plus 1. If you want to find out this value, then what it says is you'll be remaining with one value, that is one equation, that is xk plus 1 upon m. Okay, so now what it says is each successive x-intercept can thus be calculated by adding the inverse of slope and rounding the nearest integer. Okay, so now what it says is, like, if you want to find this value, find this edge. Okay, so what it says, you just have to consider this thing, it is xk value, and you have to add up the inverse of the slope, and whatever value you get, you just have to round it up to the nearest integer, so you won't be getting that aliasing effect. Okay, so this is one value that we have with us, that is xk plus 1. Okay, as of now you just keep this thing with you. We won't be having like such example for this, but yeah, you have to study this thing. So now what we have is simplified method for edge intersection calculation with scan line. Okay, one more thing we have, one information is given to us, that is the slope. Okay, delta y upon delta x, that is given to us. Yeah, so that is yk. Okay, see what it says is basically what we are trying to do is change in y coordinate between two scan lines. So basically, as we have seen that if we go from one coordinate to another coordinate, you usually would be getting one value, that is 1. What basically we do is we try to increment it by one value only, so that you don't get like like big gap in between, or you don't get non-uniform things. Okay, so we are generally following this thing, that is it should be incremented by y value. So over here also, what we have considered is the difference of the both the pixels would be 1 in our case. That is just a simple thing. Okay, instead of taking 2 value or 0.5 value, we'd be taking a simple integer value, that is 1, because the difference of the both the pixels you can consider is 1. So that's why we have written yk plus 1 minus yk equal to 1. That is very simple thing that we have to consider to get the x-intercept value. Okay, to simplify the equation and to get the x value. Okay, because if we don't put one value over here, then we won't be getting the x value. So similarly, we have like taken the difference over here, that is 1 in our case, because we are going in that direction only from the very beginning. So that is what it says. And what is the next thing we have to consider is this thing. Okay, so one information is given to us, that is the what you are saying is, if we take dx equal to 1, okay, then if we are taking delta x equal to 1, okay, fine. Though what we want to do is we want to find the successive x value. Okay, similarly you can also like put this thing into the picture and you can try to get the y-intercept value. Okay, but what we want to do is we want to find the successive x. That's why we have like simply consider this thing. See, what we want to do is, for the derivation purpose of the subjective thing, okay, if we want to go in that direction, then we have to take this thing as like 1. So that's how we will be getting the xk plus 1 value, else you won't be able to get this thing. Okay, so keep this thing in mind. And then what it says is we have one value, that is m equal to 7 by 3. We have few values with us, that is delta y upon delta x. And what it says, see, keep writing this thing. Set the counter equal to 0 and increment to 3 initially. Okay, fine. What we have to do is forget everything. What you have to do is you just have this information with you, and you have one counter that is initialized to 0, and you have to increment it to 3. Okay, which is delta x. So what it says is, when move to next scan line, increment counter by adding delta x. So in our case, if your counter is 0 and your delta x value is 3, then what you have to do is you have to just add up 3 value to this counter. So your counter would be like, next value would be 3. Okay, so now what it says is, when counter is equal to or greater than 7, okay, now we have one condition. If it gets equal to, or if it is greater than 7, what it says is we have to decrement the counter. Okay, so we'll see one thing over here, how it will like find the edges. Okay, so now we have two values over here, that is delta x equal to 3 and delta y equal to 7, and our counter value is 0. Okay, so now what it says is we are at this particular stage. Okay, so now what it says is we have to, based on the algorithm, what it says is we have to increment the counter by 3. So our counter value would be 3. Okay, if it is 3, then what you have to do is you have to like go further. Okay, again what you have to do is, at the next stage, because it is not equal to or greater than 7, what you have to do is again you have to go further. Okay, so 3, and then again you have to add plus 3 value to the counter, so it would be 6 in this case. Again you have to go up in that particular direction. Now what it says is, what you have to do is again you have to add up this thing, that is delta x. Okay, so now your value would be 9. So now this is not acceptable, it is getting equal to or greater than 7. So now what you have to do is you have to again refresh your counter and you have to initialize these values again. So now your new value would be, counter would be initialized to 0, because one value we have taken, that is 6 plus 1 7, and then 8 9. So now it was getting equal to that particular thing, so we have taken 7, and then out of the two values that was remaining, now we have simply given this value to the new initialized counter. So if your counter is getting repressed, then what it says is you have to move further, okay, in this direction. So now you have to go at this particular edge if your counter is getting refreshed. Okay, similar thing is to be followed at the next stage, that is you have to increment the counter by 3 value. So now your value of the counter would be 3 in this new case, so that is 5. Okay, 5 ho raha hai. Again what you have to do is you have to add up this value, and then your new value would be 6 7 8. In our case, again this is getting refreshed. Okay, so what it says is 6 7. Okay, and then you have to, like, you have one value remaining and you have to refresh the counter and you have to give this one value to the new counter. Okay, if this is the case, then what it says is you again have to move to the next pixel. Okay, so we have like we came here because of this counter. Okay, now again what it says is we have to add this 3 value. Okay, so you would be getting new counter value, that is 4. Similarly, next value would be 7. Okay, So now based on this thing, now we don't have anything that is remaining in our case. So what you have to do is you gotta simply like keep your counter 0, and if this is the case, then what it says, you have to simply like take the new pixel and you have to like stop there. Okay, so this is what it says, simplified method for edge intersection calculation with scanline. Okay, this is how you can calculate the particular edges. Okay, so based on the slope you can do this thing, and you can consider this case for your like for your example also. This is based on the counter information. Okay, करना कुछ नहीं है. Initially you have to start with 0 value and you have to add up this delta x value each and every time you go with this thing, and whatever value is like getting higher than 7 because of the delta y. अगर आपकी केस में delta y की value 8 है, तो you have to go up to that particular point, and if it is getting up to that point and few values are remaining, then what you have to do is you have to refresh the counter. You have to again initialize the counter from 0, and then you have to put up the values that are remaining. If you are 3 or 4 values that were like out of that particular counter, then you have to put it in the new counter, and one information you get is you have to proceed to the next pixel. Okay, so that is how you have to like simply consider this thing. Okay, ये simple edge intersection है, and the next thing that we have with us is the sorted edge table in scanline polygon fill algorithm. Okay, so now we have one more thing. Instead of doing all of this thing, what it says is try to maintain one like table based on the points that we have with that particular polygon. Okay, with that particular object. So what we do is to try like to efficiently perform a polygon fill. We can first store the polygon boundary in a sorted edge table. How we can like similarly how we can do this thing. So we'll try to analyze each and every point, whether a line is coming to that point or a line is like going out of that point. What are the things that are connecting that particular point? So if we have this information, then we can simply store that boundary information in the table. Okay, so it contains all the information necessary to process the scan line efficiently. So we'll see this thing, how it can do this thing. Okay, by the example. So we use bucket sort to like store the edge sorted on the smallest y value of each edge in the correct scan line position. Okay, so once you have all of this information, then we'll do a sorting kind of thing to get the like values in the increasing order, and so that it could be like processed correctly. Okay, so only the non-horizontal edges are entered into the sorted edge table. Okay, that you have to keep in mind. Okay, so it will work for this particular thing only. And we have one example over here. So we have one shape that is having multiple points. So as you can see, we have A, E, D, C, and B. Okay, so we have in total 5 points. Okay, so now we'll try to pass our like scan line from this particular point, and we'll try to get some particular like some information out of that point. Okay, so very first point, if we start from the bottom, so our very first point that would be like intersecting to that particular line segment, or you can say the scan line, is the A point. Okay, so based on the A point, based on the A point, you'd be having the information like wise. So basically what it says is from the A point, which are the things that are like which are the things that are going out of that particular point. So what it says is we have one line that is going out of that particular point is YE. So you just name it as a like for the scan line, we have just given one alias that is YA, and similarly for this particular point that is A. Okay, so one thing that we are getting out of the point A is E, so we have named it as E. Okay, YE. Okay, now similar thing, we have one more thing over here that is for that particular point. Okay, and we will name it as, so the scan line would be like depicted over here with the YA with the Y notation, and the point would be depicted over here with the notation that is XA. And how we can get the information with this particular thing is with the inverse of the particular line. So in this, at this stage, we have this information that is 1 upon A. So this is the slope information that it will store, and that is how it can calculate the value of that point. Okay, with the help of inverse of that slope. So at this stage, we'll be having 1 upon MA. Okay, out of that, we are again getting one more thing that is AB. So we have to store this information of AB also. So we are getting one line out of this point that is YB. Okay, and our point information is stored over here. And again, what we have to do is we have to store the slope over here. So our slope information would be 1 upon m ab. Okay, so now out of a single point we got like so many things. Okay, so it will just try to like store each and everything of the available thing, and what it will do is it will go ahead. Okay, so now the next scan line that passes from the D point, and we name it as YD. So again, what it do is it will try to retrieve the information. Okay, so very first thing, as you can see, it is going out of the point D is the scan line. That is YC. Okay, this is going over here. So you need to like get this information out of that particular point. Okay, so YC and the point name is written over here is XD, and you will be storing the slope information also, that is 1 upon m bc over here. Okay, because we are storing the information of this particular line only. And in short, you'll say that okay, one more thing is going out of that point is de. So it will store this particular information that is for line ye, and this information is about the particular point that is d. And then we have to store the slope information also, that in which direction you are like your line is going. So this will say that okay, this is the particular thing that we have with this point. Okay, so similar thing, it will now pass from the point that is C. Okay, and you name it as YC. So it will store all the information that we have with the YC point. Okay, so we have one information that is it is going to like one point that is B. So we'll name it as like YB. So this is nothing but the information of that line. Okay, you name this point as XC, and then we will be having the information of that slope, in which direction it is going. So we have to store this information also. So it is giving us 1 upon m CB. Okay, so now you'll say that, oh sir, why we don't have this information? Why it is like stopping over here only, and it is not showing the information of B, A, or like this slope information? Because of the thing that we already have. Okay, because of the information that we already have out of the previous scan line. So if your previous scan line is having this information, we have this thing. See, we have this slope information that is MAB. Okay, that is coming out of the point A. Okay, that is XA, or you can say the scan line YA. Similarly, YD information is there with us, and similarly YC information is there with us. So we don't need that information. Again, it is not passing through E because we have the previous information with us that is coming out of the A and the point D. So we did not have to scan the E point line over here. Okay, so that is what we have seen, and we'll continue with this complete thing in the next lecture also. And yeah, that's it for today. I have your attendance, and we have seen the ellipse generation algorithm in the today's lecture. And similarly, we have gone to this thing, that is the like field area primitives and how we can fill this thing. Okay, yeah, that's it for today. We'll see it in the next lecture. Okay, not a problem. Fine, thank you.